All right, welcome. This is AP Stats Unit 1.1 notes. And as you can see here, I have the answer key for the unit notes that you will kind of follow along. Again, you are highly encouraged to pause, rewind, all those kind of things. There will be times where I stop and tell you to pause and have you work ahead and try a couple problems that we just maybe talk about. And then I will go through them and explain them. There will be things from time to time that I either skip or kind of go through a little quicker and maybe mention we'll talk about this in class, and it's just a little easier to do kind of a little bit more when we have a back and forth of questions versus over video medium. But again, this is here for you to take in and get for the first time, and then when we need to, we will go over things and try more problems. By no means will these be the entirety of the problems. It's just kind of quick hitting, in note, in class type things that we will then add to as we go along. Okay, so as you'll see in each section here, we'll have learning targets that you can go through and reread later on. Maybe right now you're like, I don't even know what half these words are, but later on, if you go through it, or maybe as you're studying for an assessment or something like that, you can go through and see if you know some of these things. And obviously there's a lot more than what this might necessarily just simply state, especially in the way that the questions are worded. But this is a good kind of clarifying tool for you in terms of the targets, the objectives. Okay, so statistics. Here's the thing. Okay, here's pretty much statistics in a nutshell. One major thing, or one of the most important things of statistics, is we want to know some sort of information about a larger population. Okay, and that population could be the size of 2,000 in terms of the students at Elk Grove High School, or close to 12,000, the number of students in District 214, or millions in terms of people in Illinois. Could be in terms of all professional athletes in X, Y, or Z sport. Anything. A population is the entire group of individuals we want information of, and statistics is going to help us get some information about that population. However, it is often very difficult, illogical, or just downright not great to get that information by really asking everyone, and that's what a census is called. A census, obviously in our country, we give every 10 years, which with me doing this in 2020, in the grand year of 2020, as they say, we have a census this year, and it seems great, right? You ask all this information and all these questions to every single person, ideally, right? And let's say the census was asked every person. You have the information you need, right? So if you wanted to know the average age of everybody in Illinois at a given time, you could do that. You could ask every single person, but that takes such a long time, right? We are very far into the census taking year here, and I'm still seeing advertisements for you need to fill out your census, and it'll never be 100% completion. Let's just imagine a scenario where you could get 100% completion, like let's say Elk Grove High School, 2,000 kids. By the time you actually get your response from all 2,000 kids, the data is like out of date, right? If we ask some question to Elk Grove High School students, by the time you really found out all the information, it's out of date. Or by the time you looked at every single potato in a potato chip company to see if they have good or bad quality, it's like 3 days later, right? You need to start manufacturing and doing things. So instead of taking a census, which is great if it's logical, if it's possible, but really for the scope of this class will not be logical, because the population would be much too big or much too difficult to find something about every piece of the puzzle, every subset of individuals. We take what's called a sample, and this is the theory of statistics. This is the huge thing. Okay, we take a small sample of some size from the population, ideally chosen well. Okay, and we'll talk about good and bad sampling. And you use data from that sample to make a statement about the population. You would make an inference, which is something we'll talk about later, but to infer something about the population. Okay, The average age of a sample of Elk Grove High School students is 17.2 years. So I'm going to infer something about the all the students in Elk Grove High School. Now, that doesn't necessarily mean that our sample is exact. Obviously, if you can just think about it logically, if you took a sample of a population of high school students, Elk Grove specifically, you're not going to get the exact number from that sample. So this course is going to help you understand how do you sample, what's good, what's bad about that, and then what do you do with the data. And that's a year-long process. If you get good at this, if you find this interesting, you can find a job very easily in any place, because any company, any school, like I said before, they have the need to make these decisions. How do you know how many people need to work at a TGI Fridays on a Friday night? They look at data. They take samples of all the different Fridays that they've seen before, and they kind of project that out. It's all statistics, okay? So a very long conversation about a very small thing here, but this is such a huge idea in this class. Just sets the table for the entire year. You are going to take a sample from a population. Population's all of the people. Samples a smaller number of people, whether that's 10 or 1,000, doesn't matter. Okay? And you're going to use information from just the sample to try to make a conclusion about the population. Okay? So here we go. 2 examples here. Pretty straightforward. Obviously, you can kind of write them down. If you want to pause it and try to think about it before you look at the answers here, you can, but I think that's better suited for more difficult things later on. As you can see here, here's a kind of nice little picture. You're going to take a sample from the population, which is a smaller piece of the whole chunk, and then you're going to collect data from that sample and use that to say something about the entire population. Okay? So, example 1 here. A student council is curious what the student body thinks of the recent themed dress-up days. They survey 200 of students at the school to get a better idea. So the population, who are all of the people we want to know something about? Okay, and this is where this class is super important. Using context, using wording. You don't just say student body. You say the population is the entire student body, right? You got to use all the words. Okay, complete sentences or phrases in this class. Okay. You want to know something about the entire student body, but you didn't ask everybody in the entire student body. You didn't ask all 2,000 or 3,000 kids. You just asked the survey of 200 kids, and that's the sample. The sample is the 200 kids surveyed. Second type, the quality control manager at a bottling company selects a sample of 10 cans from the production line every hour for an entire day to see whether the volume of the soda is within acceptable limits that day. That's the other thing I love about this class. Every single question you read, if you think about it, you can see this happening in the real world because it happens in the real world. Okay, these are things that happen. People get paid money to do this stuff. Okay, so if we're taking a sample of 10 cans from every hour, that's going to add up. So our sample is going to be just the collection of cans selected throughout the day, but that wasn't every single can. We were specifically looking at the cans for this entire day, right? So it's not just from 1 hour as the population, it's all day. We were taking a little bit from each hour, okay? And then all cans of soda produced that day is the population. That's what we want to know something about, but we only did the collection that we took, okay? All right, moving on. How to sample poorly. A big thing in our class is called bias, okay? Bias is something, if you were to sample and you consistently underestimate or consistently overestimate the value you want to know. Now, obviously, that's talking about a numerical value, but if you completely or usually overshoot the right answer, or if you are undershooting the right answer, that's what bias happens, okay? If you have a sample that's taken where there's clear bias, where it's immediately known at the beginning that this is not going to be correct, you need to do it again, right? Eventually we're going to learn about random sampling, which is super important here. Bias, like for instance, if I said, you know what, I want to know the average age of Elk Grove High School students, so I'm going to sample by just doing what's here, and you can see it here, a convenient sample. It's convenient for me. I am going to take the 29 kids, or how many ever kids in my AP statistics class that I have sitting right in front of me right now, and I'm going to take their ages and average them up, and I'm going to use that as my best guess is what Elk Grove High School's whole population is in terms of average age. And again, context is important here. I'm talking about average age. Why might taking this convenience sample, which again, convenience sample here shows that it's easy to reach, okay? Easy people, it's not, I didn't do anything specific. I just kind of said, hey, who's in front of me right now, okay? Why might taking that sample not be good or show bias for the average age of high school students at Elk Grove? And the good response would be that convenience sample is going to show bias because it is likely that the students in AP Statistics are mostly, or if not all, seniors or possibly a couple juniors, which age-wise is definitely going to overestimate the average age. If every person in my sample is one of the oldest people in the building, that's not going to give me a good sample. That's not going to give me a good estimate. That's going to overestimate the average age, okay? So when you, and you could read through the tip, I'm not going to read it fully here, this thing in here. You got to say multiple things here, okay? You got to say why there's a problem. What's the problem? I took a convenience sample of AP Statistics students, and that's a problem because those students are not representative of my whole school. And how would that over or underestimate? Well, because these students are typically your oldest students in this building, at least in terms of year by year basis. So that would be an overestimate, okay? That's kind of how this works, okay? Voluntary response, another type of sample, and again, we're going to have multiple samples, and you'll have plenty of different times and opportunities to pick through them and choose which one's which, and explain pros and cons and all that kind of stuff. Convenience sample is easy. It's nice. It's great. You know, I'm Lead Nation, show up to the football game. I'm going to ask the first 200 kids at the football game, hey, what do you think about our principal? Well, that's great, but the first 200 kids at our football game are probably the kids that are involved and really love school and want to be there. They're going to say good things most likely. That's going to overestimate because I'm probably not including as many people that maybe aren't as fond of our principal, okay? Because they're probably not the people that would be the first people to show up to a game. Convenience sample, real easy, not the most beneficial thing to do, okay? Voluntary response sample also likely will show bias in the following way. Okay. It consists of people who choose themselves by responding to a general invitation. Okay. So maybe I ask you via this video right now to answer this following question. Okay. I want you to respond to me, and actually want you to do this. Okay. This 100%. I want you to do it via Remind right now. I want you to respond to the question, what do you think of President Trump? What do you think of President Trump? Okay? Do that right now. Text me. Just quick. 2 sentences. Okay? Now, as soon as I say that, certain people are going to have very strong opinions. Okay? And they're the people who are going to be right away to the phone and like, oh my God, here's the thing. Here's what I believe, okay? Strong in both directions, right? I mean, that's either way, okay? People that don't really care, they're like, you know what, it doesn't bother me. I am what I am. I don't care. I don't really follow politics, are probably not as likely to respond because they don't feel like their opinion, it's just a whatever, right? If somebody asks me about, what's your favorite soccer team in Italy? I'm not a huge soccer fan. I couldn't probably name more than 2 teams, so I'm probably not even going to say anything. Now, if you said, hey, what's your favorite baseball team in Chicago? I'm very firmly going to be on the primitive for the White Sox and say some negative things about the Cubs, okay? Because I feel strongly about that. There's probably some people right now listening to this that would be flipped. They'd be like, I don't care about baseball. I'm not really going to say anything about that. But the soccer, I can give you some things, okay? So if you invite people via an invitation, via a survey, those strong opinions are going to come out, okay? And if those strong opinions technically tend to go in the same direction or often go in the same direction, you're going to have bias, right? You're going to have people that really, 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 really dislike something and are going to mention that and say it. right? Look at the comments on any kind of like internet post, right? It's either crazy like on one side or the other. There's not people saying like, yeah, I kind of agree, right? It's either people saying like, you're an idiot, or people saying like, this is the greatest thing, and put some meme like showing that they love this post, right? So you're going to get the strong reactions. Now, you want to maybe decide or to have an idea of which direction that might be, depending on the problem. Obviously, you're going to have to explain that. And you'll see an example here in a second of what that is. But you're going to have bias because of those strong opinions going one way or the other. Okay? All right. So, again, I don't think there's really much that you have to do here on your own. You could pause it and try these. But here's kind of what we got. For each of the following situations, identify the sampling method used, then explain how the sampling method could lead to bias. And again, when you do that, be sure to identify which direction the bias would be, either over or underestimating, depending on context, okay? So number one, a farmer brings a juice company several crates of oranges each week. A company inspector looks at 10 oranges from the top of each crate before deciding whether to buy all the oranges. Again, real world scenario. These things happen. And the hard thing about real world scenarios in this class is sometimes you have to comprehend what that real world scenario might be and how people might act in that real world scenario that would relate to a statistical sense, okay? So this is called a convenience sample. Why? He just took the first 10 that he saw on top, right? He didn't dig down. He didn't kind of sort them out and kind of like number them out or anything like that. He just kind of took the first 10 he saw. That's a convenience sample, okay? Typically, convenience samples will lead to bias. Here's why in this case it leads to bias in which direction. The orange is on top, and again, the wording doesn't have to be exactly like this, but there are certain things you're looking to say, right? So obviously you need to answer the question. That's helpful. Which one did we use? That's a convenience sample. The oranges on top are likely to be in better shape or in better quality than the ones stuffed down below. Or you could also think of this, maybe the farmer knows that they're going to just look at the top ones, so that he's going to pick the best ones and put them on top on purpose. But also if he's been driving around all day, the ones on the bottom, not many people when they go to the grocery store are digging down to the bottom because they know that those have been kind of bruised and bumped all day long, right? So the ones on top are likely to be better quality for any of those reasons. Meaning the sample likely overestimates the quality of oranges in the crate, right? The company is likely to see better quality from these 10 oranges than if they did all of them, or if they did a random sample of all of them and kind of got some good and some bad, okay? So you're talking about why there's an issue there, and then in which direction it estimates the bias, okay? We don't want bias. There's gonna be bias sometimes just because things happen, and we'll talk about that. But we don't want to implicitly create a situation where bias happens, okay? ABC program Nightline once asked whether the United States nations should continue to have its headquarters in the U.S. Viewers were invited to call one telephone number to respond yes and another for no. There was a charge for calling either number. More than 186,000 callers responded, and 67% said no, okay? So this is a voluntary response. They were inviting or asking people to respond, right? So just like I said in the thing earlier, to text me, or if you got an email saying, hey, respond to the survey if you want, right? It's not necessarily required, it's just you're invited to. Since callers decide whether to call or not, and especially with a charge to call, and that's a big thing here, the sample doesn't likely represent the entire population, okay? If you don't really care about this question, you're not going to pay to call, right? But if you're like, you know what, I need to call, I really feel strongly about this, I'm going to spend the $1 and I want them to hear my voice because I have an opinion that is very clear and stated here, you're going to call, or you might call, okay? Whereas the people that just don't care as much, they probably won't call. There's probably also people that do strongly care that still won't call, but a higher likelihood of the people that are calling are likely to be either one way or the other, okay? So likely it's an overestimate of no's. Likely, 67% of the people that responded said no, but if you really got everybody, there'd be some people that said yes, they just didn't respond because they didn't feel as strongly, right? It's just that the no people here seem to feel strongly. Now, are there some yes people that feel strongly? Yes, there are. And that's probably the other 30%, right? If 67% said no. But there's probably a higher percentage that are showing up in the no category than likely would be. And again, you don't necessarily know that for sure. That's the one thing that kind of stinks about stats, is you're taking a sample to make a judgment about the population. You don't actually have all the data, so you don't really know, but you're trying to make a best guess. And when you ask questions like this in this way, you're not getting a good guess. You're likely to create bias, okay? All right, so that's great. We don't do those things. So what do we do? Huge thing in this class. It's called a simple random sample. A lot of times you'll see it SRS for short. And here's the stats definition, and then we'll obviously talk about what does this really mean, because that's what a lot of this class is. This is what it says, and then what does this really mean, okay? An SRS, or simple random sample, is of size n. Now I'm going to just kind of do a size of 20. And that means I'm taking a sample of size 20. So there's 20 people in my sample. So take a sample size of size 20, consists of 20 people, obviously, from the population, chosen in such a way that every set of 20 individuals has an equal chance to be the sample actually selected. So an SRS is a method by which, if you're taking a sample from a population, and let's say for this case, I decide I want to take 20 in my sample, every possible grouping of 20 people could be possible, okay? So if I wanted to take, like in this case, in layman's terms, and I just changed it to 10, but here we go, okay? In layman's terms, or more straightforward, if I wanted to pick a random sample of 10 kids from our school, just 10, an SRS would only occur if every possible group of 10 could be picked. So every possible group of 10, here's what that could be, okay? Every group of 10 of you listening right now could be the 10. It's not likely, right? If I took a random sample from 2,000 kids, that the 10 people just happen to be the 20-something people that are listening to this video, it's not likely, but it's possible, because it could have happened to be you 10, one after another, okay? It could possibly be 5 boys and 5 girls, but it doesn't have to be. It could be 2 boys and 8 girls. It could be anything. It could be 1 freshman, 2 sophomores, 3 juniors, and 4 seniors. It could be. Doesn't have to be. Okay? It could be all seniors. It could be all freshmen. Okay? Now, once you start classifying those, it seems like it's less likely to happen, but those are possibilities. If I say at the very beginning, okay, I want 10 kids, but 5 have to be boys and 5 have to be girls. So like I get 5 boys and I stop picking from boys, and then I pick 5 girls, and then I'm good. That is no longer an SRS. As soon as I say it has to be this stipulation and this stipulation, and cannot be any grouping of 10, it's no longer an SRS. Doesn't mean it's a bad sample, it's just it's not an SRS anymore. Okay? So the big thing about an SRS is every possible grouping of that size is possible. Okay, and there's 3 usual methods we do this. Okay, 3 methods we use for picking an SRS is we pick from a hat, which is where we take, let's say if there's 29 kids in a class, we put 1 through 29, or we put their names, but if we just label them 1 through 29, let's say, and then we pick the first 10 people, and number 1 might be Susie, and number 5 might be Tom, and those are the 2 people, and then we can go from there. Table of random digits, which I'll explain in a second, and then use of technology, which I'll explain in a second, which is using a feature called randint, or random integer, okay? All right, so we'll talk about the 3 of those. Now, all 3 require an explanation, and you're going to see questions both in this notes and then more likely even afterwards, where I ask a question and you have to explain how would you do it. Okay, you can't just say I picked from a hat. Okay, you have to explain to the AP reader, thinking AP test time, right, that they understand, you understand the process, not just the words, right? So picking from a hat is great. You might not know what picking from a hat is. They're going to pretend like they don't. You need to explain it to them. So here's what picking from a hat would look like. There's 29 kids in the class. I label them 1 to 29. Okay? I label 29 pieces of paper 1 to 29, and I put those crumpled up in a hat. I randomly pick one after another, and each number that gets picked corresponds to one person. That person gets picked, that person gets picked, okay? And likely you are taking the number out of the hat, so you can't have duplicates. There are times when you could have duplicates in terms of the process and you don't want to have duplicates, right? You don't want Susie to be picked twice, so you might have to explain that, okay? And then you say that those 10 people picked are your sample, okay? So here's what a table of random digits is. And again, feel free to pause it if you want to go back and like, what did you just say? We're going to go over everything in class multiple times. This is the first unit. You're going to see this stuff over and over and over. It's not a big deal if you're kind of still like, okay, I kind of get it, kind of don't. We'll talk about it, okay? But the best way you can come out of this is by having some semblance of an idea here, okay? Table of random digits is a long string of digits 0 through 9. All the digits, there's 10 technically digits. And each digit was again, 0 through 9, right? Equally likely. So what somebody did at some point in time, I don't know who, I don't know when, they said, okay, what's the first number going to be? And like if you look down here, you can see line 121, okay? If you think of this as like a table. Line 121, they said, okay, random digit, 0 through 9. Oh, it's a 7. Cool. And then let's do it again. Random digit. Oh, it's a 1. Cool. And they did that over and over and over, right? Whoever's doing that, they don't probably make a lot of money, okay, unless they do a lot of their stuff. All right, and they have this long string of numbers all the way going down the line, and each number is from 0 to 9, and each number was randomly selected, okay? So there's an equal chance of giving a 7 as a 2. You could have 7 sevens in a row, possibly. It's not likely necessarily, but it's possible, okay? The entries are random and independent of each other. Independent means they don't affect each other, so if you got a 7, that doesn't mean the next one can't be a 7. It's just, start over, okay? You choose an SRS in 2 steps. First, you have to label. Same thing. This is step 1 for every one of these scenarios. You give every member of the population a label of the same length. Now, that's different, okay? So if there are 20 letters, of which I'm considering these letters here, okay? You label them from 1 to 20, but notice I didn't label it 1, I labeled it 01, okay? So if you have 01, that's considered 1, okay? And the way you know how to label it is based on how many numbers there are in the population. If you have 20 numbers in the population, 20 is a 2-digit number, you go 01. If there was 200 letters, the first number would be 001, okay? And you'll see why in a second, okay? And then the second thing you do is you go that many digits, 2 digits, at a time, over and over and over, okay? So notice, we're going to just use line 121 here, okay? Notice there are 20 letters in the population, okay? We're labeling them from 1 to 20. If I got a 10, 10 would be M, right? If I got 16, 16 would be T. All right. We are going to start at the very beginning of the line and go 2 digits at a time. The first 2 digits is 71. The reason we're going 2 digits at a time is, again, because this is a 2-digit number, okay? 71. Is 71 one of our labeled digits, 0, 1 to 20? It is not, so we just keep going, okay? 48. Is that one of our digits from 0, 1 to 20? No. 7 and then 0 is 70. Is that number? No. 99, is that one of our numbers? No. 84, is that one of our numbers? No. 29, is that one of our numbers? No. 07, see how that works? 07 is our first selected individual or letter here. So J would be the first thing in our sample, okay? And if I kept going, 71, that's not between 1 and 20, 48, 63, 61, 68, 34, 70, 52, 62, 22. This is not a very good line to pick. 45, 10 would be the next one. Okay. 25 doesn't work. Okay. And in this case, you're like, well, shoot, I need to pick 4 and I only got 2. You just go to the next line. So you would go to the next line, and 13, that's good. 87, no. 38, no. 15's good. So like 13 and 15. So those would be my 4. Okay. It's possible. Let's say I got 07 here, and then later on down the line, I got like 07 again. Okay. You don't do duplicates. Okay. So you'd have to explain. Here's the explanation for this. Okay. And you're gonna try one in a second. You label your population from 01 to 20, if there's obviously 20 letters, okay? You look at line 121, 2 digits at a time, selecting the numbers that are in between 0, 1, and 20. If they don't fall within 0, 1, and 20, you skip them. Every number that's 0, 1 to 20 you use as your sample until you get 4 total, making sure to skip any that repeat. Okay? So that's kind of all the stuff you need to see. Okay, if you want to go back and listen to that again, try it. Okay, but you're talking about labeling. You're talking about giving the numbers of population, right? You're talking about going 1, 2, 3, 4, 5 digits at a time, whatever it is. You're talking about skipping repeats. You're talking about selecting those and actually using those as your sample. Okay, so letter A here. Use 124, line 124, to explain how you would randomly select 4 consonants from this this alphabet here. Okay. Again, I skipped the vowels and also Y, because sometimes, you know. So do that right now. Okay, and again, it's explain. Not just put the 4 numbers or 4 letters. Like, actually explain it. You know, I would label from this to this. I would do this to that. Okay? Take a minute, pause it, and we'll go over it. Okay, so here's what we do. Okay, so after numbering the contents from 01 to 20, basically what I just said a second ago, 2 digits at a time, what I just said a second ago, selecting numbers from 0, 1 to 20 while ignoring repeats and numbers 21 to 99. So you're going to have to say both of those things. You don't want anything from 21 to 99 and you don't want repeats. You take these 4 in your sample. 03, right? Because if you just did this really quickly, 71, 03 is good, 50, 90, 01, 43, 36, 74, 94, 97, 72, 71, 96, 99, 67, 58, 27, 61, 19, and 15. Okay? And then definitely want to say what those things are, right? The actual letters. Cool. All right, so I'm actually going to focus on calculator stuff a little later when we're kind of in it a little bit, but there are on Schoology some videos that explain how to do different calculator stuff. But just in a nutshell, you could use your calculator, doesn't matter which one. To be honest, again, you'll be into this a lot. Inspire is definitely going to be a lot easier with this class moving forward, but 84 is definitely serviceable as well. You can pick from a lower number to a higher number some number of values. So rand int parentheses 1 comma 30 comma 5 would give you 5 digits, 5 integers, rand integer, from 1 to 30. Okay, now some of them might be duplicates, so it might be a 1, it might be 7, it might be 6, it might be 7, it might be 25. So you might have to do it multiple times if you get duplicates. Okay, so if you want to try that, you could kind of use those things. You could try to see by doing a SRS of 4, so it would be like a rand int 120, because there was 20 consonants, and doing 4. You could always maybe increase this number a little higher and just take the first 4 that are distinct or on their own. Back when I did this, I got those letters, and obviously using this set here. Okay. All right. Okay. So if I wanted to do the following, okay, I want to select 5 students at random out of 29 students. Let's just say I don't think there's 29 students in this class, but that's usually what the highest is. So let's just say there's 29 students. I want to select 5 at random to do a problem on the board. Okay, you can do this one of 3 ways, right? The name out of a hat, using one of the lines, and the rand int type feature. Okay, we're not going to go through this right now, but think about this logically. If one person said, well, I'm going to use names out of a hat, and they took the time and cut the little pieces of paper, they enjoyed doing that, right? Maybe. And then the other person said, well, I'm going to use line 125. And then the other person said, I like rand int, which quite honestly is the easiest way to do it, to be honest, moving forward. And each one of them explained, I'm going to label from 01 to 29 or 1 to 29, and I'm going to take these 5, and I'm going to skip duplicates, blah, 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 blah. Guaranteed. Okay, guaranteed. Those 3 people are going to get 5 different kids, right? There might be a couple like duplicates within their sets, like maybe Susie went for both of them or 2 or the 3 of them, but there's not going to be the same 5. Okay, and that's called sampling variability. even when you sample well, which SRS sampling is sampling well, samples are going to differ, okay? It's just that happens. You don't get rid of it. This is a thing that happens in stats, okay? We are going to talk about things later on that account for sampling variability. We're going to have margins of error and stuff like that, okay? Even when you do it the exact same way, even if you did rand int 5,000 times in a row, you're going to get 5 different numbers most of those times, okay? So each person's sample will likely be slightly or most likely completely different from everyone else's, okay? So if we were in class, we would do a little thing here, which for the time of the purpose of doing this right now, we're not. We'll talk about that more in class, okay? All right, so moving on to a different type of sampling. This is still a potentially good sampling method, these two. In my 3 years of doing stats, you're going to see these questions come up so much, stratified versus cluster. So many kids mix them up. You will not mix them up because you're going to get hit over the head with them a million times, okay? Here we go. A stratified random sample. You classify the population into groups of similar individuals called strata, okay? Similar individuals. This could be like all freshmen, separate from all sophomores, separate from all juniors, separate from all seniors. Each group are similar in terms of age, right? Or in terms of years in the building. Okay, there's a context by which they're the same, right? Not necessarily all boys, not necessarily all girls, but by age, okay? Or you could say all band students, right? All orchestra students, all choir students, okay? Those could be different things depending on what your question is. Then what you do in each separate group, so it'll go freshman, sophomore, junior, senior, 4 different groups, you choose an SRS in each strata or stratum. So let's say I have 500 freshmen, 500 sophomores, 500 juniors, 500 seniors. Then I go to those 500 freshmen, I label them from 1 to 500, and I do a simple random sample of, let's say, 20. So now I have 20 freshmen. And then I go to the sophomore room, and I take, again, an SRS of those 500, and now I have 20 sophomores. Same thing for the juniors. Same thing for the seniors. Now I have 20-ish. Okay, it doesn't have to be the same every time, but that makes sense technically in this case. I have 20 freshmen, 20 sophomores, 20 juniors, 20 seniors. My sample size is 80. I have 80 high school students. Okay, but what I guaranteed myself was that I got a little bit from each age group. Okay, which is a nice thing sometimes. It's nice to know that you're sampling at least a little bit of this group, a little bit of this group, a little bit of this group, a little bit of this group. This is no longer an SRS. Okay, I know you took an SRS in each group separately, but this is called a stratified random sample, and it's not an SRS because once you force that there has to be some freshmen, some sophomores, some juniors, some seniors, it's no longer an SRS. An SRS of 80 kids from our high school could all be freshmen. It's possible. Not likely, but it's possible. Okay, here's a nice little picture for stratified, right? You have group 1, which is similar for some reason. You have group 2, which is similar. It doesn't have to be based on age. It could be just based on whatever the question is, right? Football players, baseball players, etc., and so forth. Okay, and you have 4 different groups which are all similar in some way. And then you take a little SRS from there, a little pocket of these people, a little pocket of those people, a little pocket of those people, and those people combine to make the overall sample, okay? That's one thing. And again, the numbers don't have to be the same. It could be 20s across the board. It doesn't have to be, okay? Likely it would make sense that maybe kind of proportionate to how many people are in each group, but again, it doesn't have to be, okay? All right. This is kind of hard to see here, but you'll maybe be able to see it a little bit. These are all different color coordinated, so they got split into the different colors. And then you took a small sample from each of those colors. Again, you can see they're not exactly equal sized, and they're not perfectly proportionate to like a 1 to 5 type situation, but you get a little bit of everybody. Okay, that's a stratified. So how do you know you're dealing with a stratified random sample? Very easy. The population was split into groups that are similar, or homogeneous groups, similar to each other separately. Okay? Then you take a small sample, SRS, from each separate group and combine it together. The wording will always be the same. Okay, different context, but same wording. Okay, cluster sample. Cluster sample is different. Cluster sampling groups them into individuals that are located near each other, which is called clusters. Okay, it doesn't have 100% have to be like really near to each other, but here's the big thing. Okay, each cluster is a well-mixed representation of the larger population. Okay, that's got to be huge. Okay, so if I wanted to do, let's say I was taking a cluster of like a cluster sample for students, and I separated our Elk Grove High School building into small hallway sections. Okay, and my classroom, which is down where it is in 115, where Miss Bouget's class and Mr. Carlson and Miss Mulaney / Lee, whatever you call her, Miss Smith, like that little hallway, that's a cluster. We're all kind of close together. Okay, and let's say I wanted to look at something related to SAT scores. It's possible that depending on when you ask that question, I could have my AP Stats kids, Bouget could have her Calc 3 or AP Calculus kids, Carlson could have his AP Calc kids, and Mulaney could have her Honors Algebra 2 kids. Even though those people are really close together, if I'm looking at average SAT score, that's not a well-mixed representation of the larger population, because most of those people have a higher than average SAT type score. Okay? So it needs to be a good mix. All right, so let's understand that first. Okay? But they're located near each other, and it's a good mix. Okay? Good mix of the population. And then what you're going to do is you're going to have multiple clusters, right? You have my hallway, you have the English hallway, not as fun. You have the history hallway, not as fun. You have the foreign language hallway, not as fun, right? Is our hallway, obviously. You have all these different clusters. You're going to pick randomly one or two or a few of those clusters. And here's the kicker. You're going to ask every single person in that cluster, and they're going to be part of your sample. So if like my hallway was a cluster and we got picked, every student in those classes would get asked the question, what was your SAT score? What was your SAT score? So that's why they must be heterogeneous or well-mixed groups, because in any given cluster, you should be getting a good mix of what you're looking for, okay? So layman's terms, right? Groupings based on location, closeness to each other. Super important that these are good mixes of the population. Doesn't have to be 100% accurate, but a good mix of the population. Okay? Take one or two or a variety of clusters. If it's blocks in Chicago, you might take more than 2 blocks. It might be like 20 blocks. Okay? So it just depends on what you're looking at. In a hallway situation, it might just be 1 or 2. You take 1 or 2 or some number of clusters randomly selected, and you ask every individual, every member of those clusters. So maybe the English hallway and the math hallway. Every person in that hallway at that time gets asked the question. Okay? So here's how this works. Okay? Group 1, well mixed, close to each other. Group 2, well mixed, close to each other. Group 3, well mixed, close to each other. Group 4, well mixed, close to each other. Group 2 and Group 3 weren't even selected. Nobody in those groups got asked the question. Group 1 and Group 4 were selected. You're going to ask every single person in those groups, and they become the sample. Okay? That kind of makes sense? Cool. All right. Stratified versus cluster. Again, FYI, cluster is not an SRS, because as soon as you say these people have to be selected and these people can't be selected, you're creating a situation where not every possible scenario could happen. It really could have been everybody in Group 2, and as soon as you say Group 2 can't be part of it, not an SRS. Okay? Now, SRS is great. Cluster is great. Stratified is great. The problem is going to be, what do you use when? Right? What do you use when? It might not be easy to do an SRS in Elk Grove High School building, because you're going to have to track down all these kids, and some might be in the gym, and some might be in the math hallway. But a cluster might be easy if you have a good mix, because then you could just go to our hallway and ask everybody, and it takes 5 minutes. Okay? It just depends. All right. So a couple things to think about here, but again, another little diagram. Stratified, you got a little bit of everybody, but each group is homogeneous in nature. And then cluster is each grouping is heterogeneous or a good mix, but you only take one or two of those and you ask everybody. All right. You can see kind of some things there. I'm not going to read every single thing there, but here's what I want you to do, okay, before I scroll the answers. In this you try section here, okay, determine whether a cluster sample, stratified, random, or neither of those was taken. I know, curveball, crazy. Explain why you picked your answer, okay? So explain why. You know, a stratified might be they separate them into homogeneous groups and then took a small SRS of each group. Or a cluster might be that they were separated into heterogeneous, well-mixed groups based on location or proximity, and then they picked everybody from one or a couple of those. Okay, so pause it, try those, and then we'll take a look. Okay. So first one, teacher wants to know the true proportion of all students in their high school that prefers Pepsi over Coke. Say it's representative sample. That's huge there, right? That word, representative, right? We want to get a sample that represents the population, right? If we're taking a sample and trying to say something about all the kids, you're not going to say the right thing if it's not representative, okay? You might not exactly hit the boat, but it's going to be close or close enough or often enough be close enough. So take a representative sample. The teacher randomly selects 5th period lunch, a closed campus school, and ask every student with that lunch period what their preference is in terms of Pepsi or Coke, okay? Well, if you're selecting 5th period lunch, in terms of Pepsi over Coke being the context, is everyone in 5th period lunch going to have the same exact opinion, or is it going to be a good mixture? And that's pretty easy to understand. It's going to be a good mixture, right? They don't determine lunch periods based on your Coke preference, okay? So 5th period lunch versus 4th period lunch versus 6th period lunch, each of those is considered clusters for a couple reasons. One, the students in terms of this context is a good mix of students in terms of their answers, right? Even if, quite honestly, they're all seniors, even if there's some common trait among them, in terms of this question, it's likely that they're not going to all have the same opinion, okay? So that's a good mix. And then their proximity to each other. You just go to that 5th period lunch and you ask everybody right there, okay? And that is another reason why it is cluster, is they asked every student with that period lunch, okay? So that is a definite giveaway that this is a cluster, okay? Not only do you say cluster, but you explain why. All students in 5th period lunch were selected, which is likely to be a very good mix of all types of students in the school, okay? Part B, a separate teacher in the same school as described in Part A has another idea how they can get their sample. Today is a shortened bell schedule because there are class level meetings in the theater, which are freshmen and then cafeteria sophomores, gym juniors, and fieldhouse seniors, back when you could go to school. The teacher thinks it would be a good idea to take a small random sample from each group separately and then compile the data to make a larger sample. I mean, I'm literally explaining stratified, right? You're separating them by a similar trait, and that similar trait in this case is age, okay? Now, we don't know if necessarily they all think the same in terms of this question, but you are grouping them in terms of a similar quality for some reason that might necessarily affect the answer, right? So they are grouped similarly, even though their answers might not be the same. This is definitely a way to think of this as grouping in terms of stratified, that you're going to get a few freshmen in your response, few sophomores in your response, few juniors, few seniors. In the cluster sample, there might not be many freshmen in 5th period lunch, so you might not get any freshmen. You hope you do. That's the whole point of representative sample, but you never know. Okay, so stratified, again, one of the big reasons why it's stratified, you took a small random sample from each group separately. Okay, that's definitely stratified. And then last one, still yet another teacher in the same situation has a different idea. Instead of taking smaller samples from each of the 4 grade levels as outlined in B, she thinks that it would be easier to pick one of the grade levels randomly and then ask every member of that grade what their preference is. Okay, so instead of taking smaller samples from each, she thinks it would be easier to pick one of the grade levels randomly and ask every member of that grade what their preference is. Okay, while picking all of one of the groups sounds like cluster, the fact that they're all the same age negates the idea of it being a representative sample. Now again, if they're the same age, you could make an argument that even though they're the same age, they have differing opinions. So if you said cluster and you said, it's a representative sample because based on Coke or Pepsi, they might all have different opinions, I could see that, okay? I could also see, for some odd reason, that in a given year, the vending machine switched out for this class and all of them drink Coke now instead of Pepsi, and there's some reason why this grade level really likes one or the other, okay? So it's kind of nitpicking there between the two, but again, one of the reasons why I did put this, since it's kind of a vague answer to be honest, is you really have to kind of pick it apart and explain, okay? There's not many questions that are going to be, you can explain yourself into an answer, a different answer, but you definitely have to have the explanation piece there, okay? So the first two are very clear cut, the last one's kind of a gray area. All right, systematic random sample. I know this is long, and I get it. We'll be okay. Okay, systematic random sample is a type of sampling in which sample members from a population are selected according to a random start point and a fixed periodic interval. Okay, think about this logically. Okay, let's say a grocery store knew that there was going to be 1,000 people in the building that day. They just knew. Okay, there's some way they knew. Okay, and that's maybe illogical to think about, but maybe they knew that there was going to be 1,000 people. Maybe it's a Thanksgiving promotion and they're only letting 1,000 people for the deals, whatever the case is. But then they want to take a random sample somehow. So since those 1,000 people are going to show up at different parts of the day, they have maybe one checkout line and they're like, okay, I want 30 people for this survey question from the whole day. How was this experience? So they randomly pick a number from 1 to 20. And then starting with that customer, they ask that customer and every 20th customer after that the same survey question. So let's say the 5th customer is the first person to get the survey. And then 20 people later, the 25th customer gets the survey. And then the 45th, and then the 65th, okay? Or maybe like it's a free coupon or something like that, right? The every 1,000th person is a winner kind of thing. Every 20th person is a winner. Why this works nicely in some ways and why it's difficult, and the sampling interval that you can see there is dividing the population size by the desired sample size. That if you knew you had 1,000 people and you wanted a certain sample size, you could kind of work backwards to figure out how many people you have to ask every time, like every 20th, every 30th. Why it's kind of nice is because the people that go to the grocery store in the morning are very different than people in the afternoon and different times. And if you ask a little bit throughout the day, you're getting a good representative sample of all the different people that go. Maybe the older people in the morning, maybe the moms, stay-at-home moms during the day, maybe the people getting off of work later on, maybe the people that just go out late at night, whatever, okay? You don't see this often, really, to be honest. Of all the things we've talked about, it doesn't happen as much as some of these other ones, but it does come up, okay, and it is nice to know, okay? So you can see here, you don't really have to write this one out. This is not really that big of a deal. Six Flags wants to survey a random sample of 50 of the first 1,000 entrants on a given day. In this case, they said the first 1,000, so that kind of makes sense. They might not know how many are going to be there total, but they just kind of want to get an idea of those first 1,000. They randomly decided the 13th person will be the first selected, and then they divide the 1,000 entrants by the sample size of 50, get an interval of every 20 people. So then the 33rd and the 53rd and the 73rd and blah, 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 blah. Okay? And a potential, albeit rather unlikely scenario is that if for any reason we would expect a specific pattern or result such that every 20th person would not be a representative sample, then this might not be a good method of sampling due to the potential bias. So if we think that you would assume that like every 20th person is just going to be a random person, right? And there's really not that you could predict about that, but maybe let's say like it's like a school day, right? A school bus day, like camps and stuff or something like that, and there's like 100 people on a bus, and every 20th person means that like 4 people in that sample is from the same school, the same age, the same population. You then do that 4 or 5 times, and you got a couple different sets of like data points in your sample that really are not very representative of all the other people coming, okay? If that's a scenario, you probably don't want to do this. But otherwise, if that's not likely to be the case, this is possible. Now, it's difficult to do, right, because it's all day, but there's good and bad, and that's one of the questions you're going to start to think about is what's some pros, what's some cons of these different sampling methods. All right, So switching focus here a little bit. Last page here in the notes, I know for 1.1 at least, I told you I get wordy, but hopefully try to explain it well. There's different types of forms of bias. So we talked about what bias is. Bias is when we either consistently over or underestimate. If I asked you right now, how much homework do you plan on doing for this class? Likely you're going to say more than what you probably will. You're like, yeah, I'm going to do 3 hours a week and, I'm going to study and all this stuff. And then later at the end of the year, you're like, yeah, that didn't happen. Okay. Why? Because I want to hear that you're going to do a lot of stuff and you want to do a lot of stuff and you're probably going to overestimate, right? You're probably going to say higher. That's bias. Okay. Undercoverage. Here we go. Undercoverage occurs when some members of the population cannot be chosen in a sample. I want to sample everyone in Elk Grove Village right now. I'm going to get their opinion on something. So I have in front of me a directory of all the registered landlines. And landlines are like the home phones, right? The ones that are like in your house, not a cell phone, in your house. I have all registered landlines, like, olden days. I am this old, but not that old that I use it all the time. Where you use a phone book, right? That whole thing. Okay. And I look through all of the landlines, maybe from a phone book, and I take a sample of those 1,000, and I take maybe 30, and I call those people. Okay? But I want to know something about all Elk Grove High School people. Elk Grove Village people, sorry. What's wrong with that? By saying I have to do landline numbers, there are lots of people in Elk Grove, probably more so than not, that don't even have a landline. Myself, my wife, we've never even had a landline. We just have our cell phones, okay? So I wouldn't even be included, even though I'm not at Elk Grove. I'm in Arlington Heights. That's undercoverage, right? You're automatically, by just the way you're doing the sample, you're not allowing everyone to be part of the sample. Not everyone's going to be part of the sample, but you're automatically saying this group of people can't be part of the sample. And that's important, especially when something about those people that might not be included have something similar about them. Like, for instance, a lot of the people that probably don't have landlines are likely younger because they just have cell phones. And if there's some reason to believe that the younger generation or younger people in Elk Grove Village would answer differently to this question, whatever it was, than all those other people, there's going to be inherent bias, either over or underestimate, depending on the question, okay? You're not doing it the right way. You're not doing it in a way where you, from the outset, believe that you have a good sample, okay? So under coverage, you're not allowing every possible group of people to be part of it. Also homeless people, right? It's sad, it's unfortunate, but people that don't have a home probably don't have a landline, right? They also might have a cell phone potentially, but there's things like that, right? Groups of people that are not being considered for the sample. Okay. Non-response occurs when an individual chosen for the sample can't be contacted or refuses to participate. Okay. Case in point. End of the year, I always do like an end of the year survey of like, hey, what'd you think of the class? What'd you think? Positives, negatives, Turkey Thursday, blah, 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 whatever. Okay, last year was a goofy year. I had a number of people that last 2 months I barely saw. I still did the survey. I did not get everybody to respond, even though I texted and reminded and all that kind of stuff multiple times. They just decided they didn't care. They didn't do it. Didn't matter to them, okay? Which sucks, and I hope you don't do that, but it didn't, it's not that I did it like poorly, they just didn't respond, right? Or maybe I couldn't contact them because they chose not to be contacted. So non-response happens when those people or certain people refuse to participate, okay? And that a lot of times happens from like surveying type situations. Like I send you this survey and then please respond back, right? You go to like, an ice cream shop, and at the end they're like, hey, look at the survey down below, and tell us what you think. And I'm like, cool. And then I throw the thing in the garbage, right? I don't do it. That's non-response. So they didn't get my opinion. I might have had a great opinion. I might have had a bad opinion, but I didn't respond, so I'm lost in that. And again, if the people that refuse to participate, likely the people in this case that refuse to participate, whatever was going on with them likely differs from the people that cared to respond, okay, for whatever reason. Okay, systemic, it's hard to talk, pattern of incorrect responses in a sample survey leads to response bias. Response bias is this. Here you go. And I kind of said one kind of earlier when I talked about the homework. But let's say a dentist, first question they ask all of their patients as soon as they come in: how many times a day do you brush your teeth? How many times a day do you brush your teeth? Or how many times a week do you floss? Those two questions, either one. You are very likely to get a systemic pattern of overestimates because the patient is wanting to impress or lie or whatever you want to call it to the dentist to make it seem like they're not a bad person, right? Because, you know, they have this stigma that you should be doing this, and damn, I don't, but I don't want you to know that, because then you look at my teeth and now you're like, why aren't you doing this? This whole thing, right? So you're like twice a day and floss 5 times a week, right? Okay, response bias is when the systematic pattern typically goes in one direction, okay? Again, similar, just based on the context, similar to the how many hours you're going to study a week. You're probably going to say higher, right? For whatever reason, it's going to be higher than what it really is, okay? Especially like the first week of school, all right? That's response bias. And then this comes up every once in a while. It is super important, but it doesn't probably get asked as much as the other ones. The wording of questions is really important in terms of influencing the answers given to a sample survey. If I tell you that doing your homework is going to cure cancer, do you think homework should have a high percentage of your grade? Well, you're like, well, shoot, if this thing cures cancer, you might want to make a high percentage because then people are going to do it, right? So the way I worded it influences your opinion. If I just said, hey, do you think homework should be a high percentage? People are going to be all over the board, most likely probably not even saying all that much, because some people don't do their homework, so they're like, damn, that would suck, okay? Other people would say, yeah, do it. It's a really easy point to get, okay? So wording a question sometimes comes up depending on the way. It really is pretty clear. The other three are a little bit tricky to figure out, and sometimes there's some vagueness too. I'm not going to read it just because there's so much here. You can read through each action and effect. A lot of these I kind of already talked about a little bit. And again, you're going to see these a lot. And then the last thing I want you to do here, pick which type of bias is present in these examples here down and below, and what effect the bias might have, right? So kind of give an overestimate, underestimate kind of thing. May have, again, explained some of these. Sometimes I have the same stories every time. But see if you can go through it, and again, picking the bias and explaining why that bias happens and if it's an over and underestimate. All right, so the first one, I kind of gave that one already. I kind of said a dentist, now it's a nurse. Maybe you missed it. I don't know. Response bias, kids are likely to lie, specifically an overestimate of how much they brush their teeth, because the knowledge that the nurse might have an issue with a smaller number. A teacher asks students to raise their hand to answer what 6 times 8 is. No one raises their hand to answer. The most frustrating thing in the world. Okay, it's non-response. Non-response, I asked them to answer, people didn't. Okay, now why is this huge, right? It appears as though people don't know the answer. That's not true. People know it's 48. They just don't want to answer, or they don't like to raise their hand, or they don't like to talk. So there's going to be an underestimate, and this is what's frustrating as a teacher, an underestimate of the percent of students who would say the right answer, because I think it's barely nobody, if anybody, when really it's probably most people. So then I got to like teach again and like talk about it again, or ask like, are you kidding me? Come on. And it's frustrating, okay? Underestimate. I think is lower than really is, but since I'm a teacher and I need people to do well, I reteach. Principal wants to know what the student body thinks about the fine arts program. He asks every student in attendance at that night's concert, chorus concert. Under coverage and response bias, and you kind of can go both ways here. You don't necessarily need to say both, but you could have said one or the other. And both would cause an overestimate, okay? Under coverage, because if they're at that night's chorus concert, they're likely a fan or aficionado, or whatever you want to call it, of the fine arts program, because they have a sibling or a buddy or a son or daughter that's in fine arts. So they've spent a lot of money and time. They think highly of it. Okay. Now there's gonna be some people that are there that don't think highly of maybe the fine arts program. They're just there to support their kid. but you're more likely to see people that are overestimating that response. Okay, and then response bias is kind of that. I think that's actually what I just explained. I don't know what I just said. Undercoverage is you're not getting everybody, right? You're only getting the people that are at that concert. There's a lot of people, unfortunately, that don't go to those things, and that really sucks, and it really should change. But it's true, okay? And I know some of you probably would be in a chorus or a band or orchestra, and you know that, okay? So you're not getting the full breadth of thoughts on that. So likely you're going to overestimate people thinking about the fine arts program, because people that think less of the fine arts program or don't really care about the fine arts program aren't there. Okay, and then the response bias is that people are there are likely to say highly good things about the fine arts program more often than not. Okay, it's a lot. That's 1.1. I talk a lot. I explain a lot. But this class, you have to know, you have to understand, conceptually describe things. There's so much going on in this class. Okay, it's hard because you got to do work and you got to answer questions. You got to respond. But it's easy because if you see here, there was like no numbers. I know I put down a couple numbers, but there was no calculations. Obviously, we're going to get into stuff, but this is a good unit to show you that this class is different. Now, numbers are going to come in, and it'll be fun, and it'll be charts and graphs and probability and all these different things. But you need to understand that this class is very, very crucial to the real world, especially right now, okay? But the way you write things, the way you explain things, everything in context, you're going to hear me say that all the time. Everything in context. Don't just say they do. Like, who does? The kids. They do what? Well, they're going to lie. Lie about what? Lie about the number of times they brush their teeth. Okay, and then what about that? It's an overestimate. Overestimate about what? Overestimate about the number of times they blah, 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 blah. Okay? All right. Hope this helps. A lot longer than I thought it was going to be. But maybe you know it a lot better than potentially you would have if I just went through it.